So what I'll do is provide a brief introduction on the aim and use model that we have been working on for the past 5, 6 years, developing and working on. Just to give a background, AIM stands for the Asia Pacific Integrated Model, which is a large scale computer simulation model which was developed by the National Institute for Environment Studies here in Tsukuba, Japan, in collaboration with the Kyoto University Mizo Information Research Institute in early 1990s. Around 1997, they collaborated with developing nations in Asia to build the AIM-CG, AIM and Use country model. So there's a AIM version 1.1, 2.0 that was built in late 90s, early 2000s. It was more sectoral models. Today, what I'll be presenting is the AIM Enduse version 3.2, where we have combined all the sectors and the power systems. So I'll be basically presenting on that. So just to give a brief introduction of the AIM family of models. So we have the AIM Energy Snapshot, Backcast, extended snapshot version. I'm sorry for my voice materials. So these go into AIM CG, then the backcast and AIM snapshot goes into the AIM end use country, and we have the sectoral service demand models which are going here. And this is a national scale model which can then feed into the global scale models. We have the AIM end use global model, the CG model, and the impact model that is being used at Nice, Japan currently. What I will be presenting on is the aim and use country model, India model that we have developed in the past 5, 6 years. So it is a bottom-up model with detailed technology selections, recursive dynamic. It is recursive dynamic model. It assesses the technology transitions over time, analyzing effect of policies of carbon, energy tax, subsidy, regulation, and so on. It's multi-gases, but for India, we are just looking at CO2, and now we are basically extending to all the non-CO2 gases. So that is in process, and multiple sectors are there. So this is just a figure from one of the papers that we have. So the drivers, as most of the models, we have the macroeconomic indicators, the social policy, social indicators, the policy market indicators. Also, we look at the international agreements, specific targets that we had in SDG, the NDC, the updated NDC, and we use that to basically develop the sectoral demand models. So what we have done is the agriculture, industry, residential, commercial, transport, power sector, and uh, we developed the energy model, and we added the water systems module to this model. So the current AIM version, India version, has both energy and water integrated inside the model. Here, the electricity demand is endogenous. So whatever sectoral demands, how the electricity is used in each of the sectors, based on that, endogenously, technologies are selected for the power systems. And what we have outcome as we get the energy demand, supply mix, the water withdrawal and consumption indicators, the sectoral and technology wise fuel mix, emissions, wastewater, and also investments into fuel and technology. So this is just a sample of the outcome that we used in one of the papers, where we looked at the BAU, the NDC, the 2-degree early late action and 1.5 scenarios, and looked at each of the options such as energy efficiency, renewables, demand reduction, and CCUS when it came to the carbon budget in the global models. This was published in 2018 paper. We've also looked at investments where we basically informed that when we look at 2015 to 2030 horizon, we require 6 to 8 trillion investments, and this was also referenced in our LTS, which was submitted this year. Sorry for this. And one can see that almost 40 to 52% of the investment was to be done in the power sector, followed by industry sector. We also basically worked on the water energy transitions in India. Here, the key insights were there's a need to increase the water supply when we do what non-water constraint scenarios, and we also did like constrained scenarios and looked at the energy systems and how it impacts the energy systems. In the water constraint scenarios, we found that there would be stranded coal assets. So in addition to if we move towards 2 degree or 1.5 degree without CCUS, there would be stranded coal assets. If there is a water constraint scenario, so when our when our demand is more than the supply, we would have stranded coal assets as well. And there are impacts on system costs and future investments when water constraint scenarios come into picture. We also looked at the SDG and NDC goal achievements. So one thing we found was we could basically achieve all the NDC goals if our SDG goals. So if we become more water efficient, we still can achieve most of our NDC goals. When it comes to soft linking at a national level, we have soft linked the AIM Enduse India model with IMA Claim India, Times India, and Forestry, Land Use, and Agriculture model. And at an international level, we have soft linked it with GEMI 3, Gains, YASA's model, and AIM and Use global model here with NEES. When it comes to contribution at national level decision making, our scenarios and publications have been used for the net zero target decision making last year, for the updated NDC, which was approved by the cabinet this year around August, and long-term strategy, which was published, which was basically announced at the COP27 this year. At international level, dialogue discussions, the model scenarios have been used and basically presented at COP24, the last year COP26, for the global stocktake, UNFCCC bond. So we were invited to present India's case study and what we think about, especially when it comes from a coal phase down perspective, and this year at COP27 from a climate finance perspective. And this is just a reference of all the studies that we have done. I think hopefully have been under the, so yeah, that's about it. Thank you.